look into the technical aspects of it.
But you said something, in order to keep up, curiosity and being on a learning trajectory is almost fundamental.
Yes.
So, and that is something that is sort of an indirect capability that is not really in your CV. So what are the markers that helps you understand, will they be on a good trajectory? Because, they've done something in school and now I'm going to put them in our context.
Yeah.
And there will be stuff they have seen, but there will be a lot of new stuff for them. So their ability to learn fast and pick that up is quite important, right? Yeah. And this is one of the key topics now. If this is, communication skills, technology skills, and learning trajectory, curiosity, 3 main topics. The soft one is difficult. Is that summarizing like a lot of the thinkings here right now?
And sorry.
Yeah, continue.
Because communication skills is something that you probably can get a sample of time on, but the trajectory is much harder. And as we were discussing recently, like, you have to be aware of what people generally talk about in the scene, what people are expected to, if you're part of the current conversation on machine learning and AI, which you probably are if you're interested in the topic, what are you expected to sort of know at this point in time?
Do you have a view on that? Do you have to have, you're starting to build this view simply by a couple of interviews now, I guess.
Yeah. I'm getting more and more humble on this, especially since they started opening up the new master programs. Because I did not go to those master programs, so I don't know what's thought on them.
But also when you are interviewing more junior people that don't have working experience potentially, it's hard sometimes to measure also the skills from a more technical point of view. And there are also these kind of cliches about, you shouldn't hire for skill, you should hire for attitude. And it's more about, the potential, the kind of potential level of intelligence in some way, or curiosity, as you mentioned, and the ability to quickly learn and want to learn more, Do you have any thoughts about how to measure that in some way when speaking to more junior people? Can you get some sense if a person is, he may be able to remember some facts from a textbook, but in reality he doesn't really understand them. But
that's what you're trying to
gauge,
usually. And I haven't found a ticket yet, but just trying to find what they're mostly interested in, because if you can find their biggest technical depth. And prod around what they've been looking around in that depth. So this is a good place to start. Fortunately, there's a lot of people do thesis at companies that they weren't that interested in doing. But if you can find that thing, it's usually easier.
But I heard something that is, I think, a quite good tip if I try to understand it. It's like by taking the interview down in like, what are you passionate about, and what have you been interested in learning more about, and then you see, do they light up? How do they respond to that question? Is it a shallow answer, or do they love and go down a rabbit hole? And can you then, in a way, you're gauging how they are responding to that question, in what way, how they respond to. I guess that's what you're doing to some degree, right? And
doing, which we of course have been doing interview not in person, makes it really hard because
physically meet them.
Yeah. Because just getting into a comfortable space, you have to always interview where everyone should be at a comfortable space.
Yeah.
So otherwise they're not going to open up.
Yeah.
I think, especially for me, these days, I'm during my current, position, and when we do interviews, we have a lot of focus on the psychology side of things, and we have professional psychologists that speak and do a lot of other thinking. And I must say, I think these aspects are normally not taken in consideration enough. And I think these aspects is really interesting. So I have, at least in recent time, become very much more interested in the soft sides, the soft skills that people have. And that is, I think, super important to actually have a person that is not only knowledgeable, but also can work together in a team and be a contributor to a positive and constructive atmosphere in some way. Is that something you think about, like the more attitude and the more psychology side of the personality that people may have?
Of course, I think about that, but fortunately, that's not the kind of interviews that I've been focused.
Yeah, because you have in the interview process there are several different interviews, and there are other people who have been sort of focusing on those dimensions.
Yeah.
Cool. But you're hiring for a number of interns then. Do you have any specific projects in mind already in Schibsted, what they will work with? So
last summer we hired interns to do a really interesting transfer learning task.
Yeah.
I don't know what we will do. We're probably focusing more on doing data engineering tasks this summer, which poses sort of a more bigger challenges because it's harder maybe to make a data engineering task self-coherent. But we haven't set up the task to do yet.
So let me put you on the spot now and imagine someone listening on this and they are eager to get an internship at Schibsted.
Yeah.
Why should they do that? How would you pitch, why they should apply for an internship position at Schibsted right now?
I mean, as an employee, it's a pretty special vibe at Schibsted. People are really nice, and there's this sort of humble nerd attitude going around. This is maybe not our official, but this is my.
I like a humble nerd. That's really awesome.
That's my.
I think that is two of the most positive attributes you can have.
So, and we had a lot of people that entered our teams as an intern, and other people that have started and gone away to do big and good things. So I think it's a very good place to learn.
So bottom line, the proof is in the pudding. Interns in Schibsted, they do pretty well.
Yeah.
So it's a good place to start your career.
I think so.
And they obviously have very talented people like yourself, Egil Martinsson. And we're very welcome here, for one. Very pleased to have you. We know each other for a number of years. I'm not really sure from when, but I guess it's from Stockholm AI or some meetup groups.
I think it's actually earlier than that.
Yeah.
I know that you have been very active in meetups.
Yeah.
I don't know if this was early in maybe even 2012, 20.
Really? Could be.
I remember you organized meetups for Stockholm. No, for
ML Stockholm.
ML Stockholm.
Right.
And that was one of the first times where I had been, sort of isolated, not meeting a lot of machine learning people. Everybody was talking about the same thing. So that was a big thing.
Oh, cool.
So for you felt this, I'm in my bubble and I feel very alone in my skills in my company. And here is the ML Stockholm going on. And you met people who you could talk to. 2012.
I think it was, can it be that early or 2013, 14?
Yeah, for sure.
Something like that.
And we have a lot of, I think, common people in mind here, like Lars Sjösund.
Oh, yeah.
You know him, and Mikael Huss, I guess, as well. And Anders Huss, I guess, and Carl Tomé, I guess, as well. There's a lot of people. I think the actual sphere network here in like the AI scene in Stockholm, I think most people know, and I think a large extent to Stockholm AI and these kind of meetups as well that we have, right?
Yeah, it's I don't know why it's sort of happened, because I know that it hasn't happened it didn't happen that early in other cities, is what I've heard, but there was a very small dance group where people were very playful. I can't mention everybody, but we organized hacks together, and there was people running that weekly. And was it Anton Osegeir, Leonmark, and Jim, and people where we would just meet up at Starbucks, hack away, sit and talk, and then around that, there has been forming a group of people that.
Were you all titled data scientists in 2012-13? I think, or did you?
I was at least.
Yeah. Is that because I remember this from when we started Data Innovation Summit and all this, and this is fairly new in Sweden to have the data scientist. What is a data scientist?
I think I was called AI engineer in Campania at that time.
That's super. That now it's gone full circle, Anders. You've gone full circle. What is cool, right?
Yeah. I think I was titled bachelor student in
You're too old. Oh, good one.
But we also met up recently.
Yeah.
Schibsted as well. So we had you are starting a new AI forum, or what was it called? Yeah.
So, I mean, at Schibsted, maybe I'm not going to go into deeply, but we're a lot of data scientists and a lot of machine learning engineers. So we have always had this sort of, now a Nordic initiative, but it's been like a global initiative before where we just meet up and share experiences. And now we're starting this AI forum, which is, we're trying to, I think monthly or bi-monthly, invite external speakers, and hopefully we're going to meet up together soon as well.
Within the Schibsted sphere.
And recently we had this amazing speaker.
So I was honored to be a speaker there. Yeah, so that was really fun.
You got into the inside.
Yes.
Cool.
Yeah, very cool.
It was very nice.
And received a very nice present, I must say. So thank you very much for that. It was a pleasure to be there, and really awesome questions. I think the energy and the knowledge, the level of knowledge you have there is it's really great.
We were happy to have you. Lots of discussion afterwards as well.
Yeah. Oh, we will talk more about Schibsted and all this. So we're going to go nerdy on this one because.
Let me just say, I'm always through the years I've known you, been very impressed by your skills. So with that, we are very honored to have you here, and I'm looking forward to the discussions we're going to have. So thank you.
Thank you.
Cool. With that, perhaps we should start just to describe a bit more who Egil Martinsson is. How would you describe yourself?
Professionally, I guess I've been driven by focusing on boring problems with fun methods. And I don't know, maybe that's sort of describes...
I love that answer.
That sort of describes me, maybe even in a wider sense as well.
And what do you mean? Elaborate on boring. It's so fun framing. Boring problem, what the hell do you mean with the boring, with fun methods? Elaborate, please.
I mean, so like I studied economics. Let's start with that. That's how I started with studying. But I kind of, jumping onto this machine learning craze when it happened, my eyes started to be really big because I was interested in these kinds of classical sociological questions. Like I wanted to do research in social sciences. I was interested in psychology and economics and those kind of questions. But it seemed like it was a lot not empirical enough. And then around 2011, we started. It was this data visualization boom, if you remember.
Yes.
So there was a lot of chatter going on. Could have been on Twitter. This was 2011, so 2012, where D3JS came out.
Oh yeah, D3. That's awesome.
What is this? This is not my.
So it's a JavaScript framework where you can make visualizations, and they're so cool. This visualization, you can do trees, represent things as trees, and and circles, and
in 3D as well. Right?
I'm sure.
Yeah.
And I didn't know anything about programming back then, but I just know that this is something I want to do, because it was sort of the culture around the data visualization was a lot of I'm not going to use big words. We're just going to show the data. And of course, I wanted to get in on that. So I started trying to learn JavaScript. And I don't know if I was just so absolutely poor in understanding what this is, because I haven't written a line of code, so I just bumped my head against that, trying to do the most simple thing. I couldn't do that. But I still know that this is something I want to do, so I kind of changed my study trajectory.
So you went from an economics trajectory and now more into data and programming.
Yeah, and that was thanks to cool but useless graphs.
Cool. I mean that brings back some memories, and I know in Spotify at one point we have we call a data art competition.
Yeah.
So we just want to visualize data in different, creative ways. And then we had a competition, and the winner, did something. And the winner, he had a super, super cool kind of visualization, but no one understood what it meant. So it was a visualization that was really cool.
It was art.
But it was useless. It was art, exactly.
Very cool, beautiful.
Art, right?
Yeah, we had that joke before.
But yeah, I think the best thing is when you can combine like a nice looking visualization with something you actually do understand as well, right? That can be a bit tricky.
That is tricky.
So then you basically you changed faculty and all this, or more or less, or how did that come about? Or
back then it felt like moving like a tanker traveling up the Nile or something, because I was really doing, like I was studying, social science and business administration, economics. Yeah, BA in economics in Uppsala. So you're not only very far from any faculty where they do anything with data. It feels like you're also physically far. It's a 15-minute bike ride in Uppsala to the nearest technical faculty.
So you actually had to change faculty, or could you combine it with where you were?
I started studying statistics because there's this very good statistics institution in Uppsala, but it's kind of weird. I don't know if statistics in Sweden it must be different than the rest of the world because you're doing statistics without math, which is interesting.
What do you mean statistics without math? Do you use like SPSS and stuff then?
Yeah. And I think this is also, I've been trying to explain this to other engineers, that statistics without math is a thing that we do in Sweden. And
I guess it's not a good thing, or?
I don't know if it's not necessarily a bad thing all the time. There are good things, but it's just, it takes a long time to learn statistics. It's extremely hard because you need to reason in a completely different way. While in the rest of the world, every close to technical education starts with you doing linear algebra, single variable calculus, even if it's accounting or.
Yeah, even I did business statistics in business commerce in Australia, which is. But it is math in terms of covariance and everything like this. What we are learning about, and now you're saying you're doing statistics without doing the basic math. It's hard to
there's basic math, of course, but it's a lot. A lot of it is. There's some aspects of it. I guess you have to. Because everyone needs some statistics. So if we're going to teach everyone in half a semester to do statistics, we're going to cram down a lot in it. But then there's the other aspect, which is, starting with recipes and then learning to reason about the recipes rather than maybe starting from first principles of, starting with, I don't know how far you can start with building probability.
So it's a little bit like starting another angle. The philosophy of how the education is set up is a little bit different, actually. So you can use tools in SPSS. Yeah. It's more about how do you maximize what you use the tools for. Can you use the tools properly? You don't worry about the math, but you damn need to know which type of math should be used and stuff like that. Or how should I interpret?
I think. Since it's very applied, I'm skeptical towards the idea of learning applied things at university. But it is very applied. And it's applied for things that for conversations that you kind of find in science, doing statistical tests, hypothesis testing, but also whatever time series and survey methodology. That's not anything that I came close to when I later moved to Chalmers, I guess.
Cool, but then you had an economics background, and then you moved to Chalmers somehow, right?
Yeah.
Or how did that happen? Why did you move to Chalmers?
So I had decided, I saw these cool graphs, I want to do these graphs. So I started, thinking about how can I move over to, get into this world of data. And it wasn't a long time ago, it was 2013, but there was no, data science program, there was no machine learning program, but there was still a very reasonable idea of what that could look like in the future. It definitely involved math. So I started studying math, doing the basic math, studying that at the same time. And then I did everything I could to go to the US.
You did an exchange program there, right?
Yeah.
And why were you so interested in going to the US?
I mean, this was almost religious at that point, and that was that. Okay, so all these institutions, they don't speak to each other. Most engineers don't know that there's statistics without math. Most people that was studying what I was studying didn't even know about most of the concepts that you're dealing with in engineering. Like, they're so far away from each other. While in the US, you take a lot of courses. You're forced to take a lot of small courses. That's really how it is in engineering programs as well. You take small courses and you're allowed to shift. While when you're studying social science, maybe you decide 9 months ahead what you're going to do for a full semester, which is, that's a tall order for someone to know, exactly what they want to study. So I wanted to go there to be able to just learn do a lot of things at the same time. That's not necessarily related.
What do you think about the US educational system in general compared to the Swedish one?
I'm sure there's statistics for this, but my theory is that they produce less. There must be an English word for this. Överliggare.
That's a good one.
What do you mean with överliggare? You mean people that just stay on?
Stay on academics for its own sake.
So maybe I feel like I have a little bit of relation to this because I was just studying for a long time. You're interested in one topic and then you decide to do that. Then maybe you decide that, maybe I should study this instead. And then suddenly...
So in Uppsala, you mean like people have done a career by changing courses for 20 years?
Yeah. And then...
They exist.
Right. And I don't know, maybe there's not enough money in the world to do that in the US, but I still assume that the assignments of, matching between your capabilities and interests are easier to optimize for if you're exposed to a lot of things. And the Swedish school system is not optimized, that it's not constructed to expose you to a lot of different things.
So you're going down a path quite early, and then a little bit like what you explained with the social science setup. You're going down a path, and then all of a sudden, when you started, you have just started, and you need to go through the left door. Now you're stuck for 9 months.
Yeah, and that happens I don't know. I hope it has changed, but that happened when you were 16 until recently, because you choose at a very early age if you're going to do natural sciences or social sciences in high school, senior high school.
And this is already closing some doors and opening up other doors to some degree.
Absolutely.
We spoke about hiring before we got started here. And we can also see in US there are problems with it's a big class difference between different universities. And also you have a much higher rank or status if you come from one, well-known university versus not so much from others. In Sweden, it's rather equal, right?
It's very rare that we discuss which school people went to.
Do you think that's or let me phrase it like this. If we were to measure the average engineer coming coming out from a Swedish university compared to the average engineer coming out from an American or US university, which one would be the best?
I think you guys have to answer this because I haven't met that many American engineers.
Yeah.
What do you think?
I think the Swedish educational system is underrated a bit, surprisingly good. We just need to keep the good people in Sweden and Europe. That's the big problem. So the big tech giants, especially, they eat up and do a brain drain from Sweden to the big tech giants. But we do get surprisingly good people, I think, out of the Swedish educational system, and it's one of the strengths, in my view, in Sweden.
I couldn't tell you. I don't have any data. I don't have any background. So, would you argue that there's differences or fairly homogeneous Sweden overall? I mean, or it doesn't really matter.
I have my subjective views.
Linköping is best,
yes,
of course.
I'm very subjective in this, but compared to at least other foreign universities, they are surprisingly good.
Yeah.
I must say.
And what is your data point on that? What is your sort of empirical evidence on that?
Well, it's 15 years of anecdotal evidence, I guess.
Anecdotal evidence
I can live with that.
Evidence in the tail as well. I've suspected that we produce a lot of good engineers and lots of good people, but maybe that's despite the educational system and not because of it.
Ooh. Elaborate. Why do you think so?
Because of the self-assignment. I mean, if you are a brilliant, if you end up being like a brilliant statistician, for example, that means that you, at 16, for a random reason, maybe chose the correct, classes to do in high school, and how can that happen? Like it feels like a completely random choice. In order to go start now, I don't think you should need to do, but engineer, that's a better choice. Doing 3 years of a bachelor, and the choice of that bachelor, maybe that was you chose mechanical engineering, which is still a pretty slim choice in a world of all the opportunities that you can do, and then maybe doing the same masters.
So your argument here is a little bit like with the way our educational system is set up, how many 15-year-olds, 16-year-olds understands the choices they made, and rather it could be a better strategy to expose broader in some sense. Okay, so let's say broadly we go into engineering, but let's now expose you to engineering from many different facets, so you can find your real passion. Is that sort of the argument here? Is that you think is, so we are going down. If you're super narrow people, some people know exactly what they want to do, right? But most teenagers don't. Sort of. I guess that's a little bit my understanding of your argument.
I've never met anyone that knew what they wanted to do.
And there is a few, but
it's a really good point. I think it's a lot of random choices and people that perhaps make the wrong choice that could be an awesome star in some whatever other field. But
they never got exposed to it. They never found their passion in this way.
Good
so that's maybe we are doing okay, but there are things to improve maybe.
Yeah. Awesome. Okay, so you went to Chalmers. How did you define Chalmers as a university then?
I really liked it. I was choosing between KTH and Chalmers because it was very much based on the same assumption that if I'm going to KTH, I'm going to be stuck in this loop where I need to decide exactly what I'm going to do in 9 months before, and then I'm going to take those courses. Maybe that were poorly assigned, and maybe I was just doing things that I shouldn't be doing. But I was starting in Chalmers. I would start a bunch of classes, 5 classes, and then drop some. As you do in the US.
So you think Chalmers had a little bit different way of approaching it?
That's how I felt, or maybe I was just doing exactly how I wanted to do. But I assumed that there was more. I felt like there was a lot of freedom at Chalmers to do a little bit more of what you wanted to.
That's super cool.
Cool. And you graduated. What was the degree you got in Chalmers?
I didn't get a degree.
Oh,
no.
Sorry.
So in the end, I think I have too much high school points, but I did not take the ordinary differential equations 1.
Right.
Because I was struck by hubris and thought I could, tag that off just without taking the classes and doing a bunch of other classes at the same time. I couldn't do that.
You're an Elon Musk kind of person, I think.
So you did a lot of stuff, and then in the end, when it came down, it was like one of the early classes was like, nope, you haven't done this.
Yeah, I focus on the other classes. It was a wrong choice, but it hasn't hurt me that much yet to not get the degree.
Yeah, cool. And then what happened after university? What did you start doing then?
I mean, it's at university, for my master program, I had this idea of doing, it was a pretty simple idea, but I thought like this could be something interesting to work on. So I did a master thesis building a model, and then I just continued working on that.
A model, you mean an AI model in some way?
A machine learning model.
Yes. ML.
For what?
So it was, the simple idea is really, I mean, I'd studied classical statistics in my bachelor's thesis, and then I saw an opportunity to use one of these old boring models, survival analysis, and kind of try to see, can I mend this for a particular class of problems, which is really, you're trying to predict events. And then try to reformulate the idea of predicting events as predicting the time to an event. Because we're getting some kind of nice tricks to that by using the formulation that's been around for 100 years or something. But it's really... Oh, sorry.
So what was your thesis topic then, if you were to just take the title, for example?
Okay. VTTE, Viable Time to Event Recurrent Neural Network. So the setup is simple. You have any task that is occurring where the data is coming to you as a stream of events.
I think you should mention the application as well, because it's one of the core things that you have focused on a lot, right?
Yeah. So I did an internship at Ticktail, and we were building a churn model.
Right. And churn model means what?
Churn means you're trying to predict if a customer is about to drop off.
Yeah. Cool. And you had some kind of neural network that was called vital time to event something.
Viable time to event. So viable is a beautiful distribution, and a distribution is like a probability distribution, which it's classical. It's very well known in not agrarian science, but when you're trying to predict lifetimes. So if you're trying to predict when will people die, for example, if you're in that field of work, you know your viable distribution. I would say most people that are in the line of machine learning do not know their viable distribution, which is unfortunate because it's a pretty fun little distribution.
What would you compare it with? What other type of probability distribution would you say it's most similar to?
I mean, it's like it's one of these. It's for positive values. It's the positive version of the Gumbel distribution, made famous by Gumbel softmax. But it looks like a Poisson distribution. It just has another parameter to it.
So something that happens with certain time intervals, and you want to measure when a certain event happened, given a set of other time series events. Yeah. Right?
So for example, you have customer data.
Right.
You then maybe have a couple of years of events. They made payments. And now you want to predict when will this customer stop making a payment. I think the trick that maybe got this project into, like, it's slightly some people found it interesting was that the idea is that you, instead of trying to formulate how do I predict if a customer is about to stop, you think of how do I predict when they will pay again? Because if you're predicting when they will pay again, the inverse of that is, they will not pay.
Yeah, right.
And a good definition of not paying is, paying in an infinite amount of time.
So in a way, you're reframing the problem. You're having a very concrete understanding of what you want to look at churn.
Yeah.
But you're reframing the problem definition, so you're coming at it from a different angle.
Exactly.
And with this, you can find other types of data points that you can work with.
Exactly.
Like event data.
Yeah. Because event data has some peculiarities, like there's uneven spacing between events. People pay at odd hours. And another thing is that if we have a recurring payment of the customers pay once a year, and now it's November, I still want to use the last 11 months of data. But I haven't had any event, so I don't know between now and like their last payment, I don't know when they will pay again. And that is framed exactly as it's in when we try to frame how do we use live people to predict how long people will live.
Yeah.
Survival analysis.
But the bottom line here is actually it's very clear, we want to predict churn.
Yeah.
But we can't find the data points if I go in one way to find something to work with in order to build a model. So here is a little bit like, well, I have this data. What if I go another way then? Can I actually come to a result based on the actual data points that are available, like payment event data?
Yeah.
So it's a little bit like, okay, this is a really hard problem to solve, but it's because we've been looking at the wrong angle at it. If we look at the other angle, we have data.
Yeah. It's maybe one of these things where we have a very clear conception of what it means to be a churned user. But when we're trying to actually materialize that into a reasonable query, it gets extremely arbitrary.
I mean, cool. I mean, it's also related to I guess, forecasting type of models and whatnot. But if you were to just describe, what was the main contribution of the thesis work? How would you try to describe this is what we came up with and how it works?
It's really, there's survival analysis, there's recurrent neural networks, there's deep learning. Match them together. It will work exactly as you expected.
Very nicely, concisely described, I think.
So you took two fundamental types of methodologies or
Yeah.
And then let's mash them up.
Yeah.
Let's do something and it performed like it should.
Yes.
So it was a good result.
I think I found it interesting as an interesting result. I found some things interesting that when we looked into this later, which is, okay, so imagine if we have a model where we're trying to predict what's the probability that a user will do something in 30 days. And we train a neural network on that, or we train any model. If we instead formulate it as let's try to predict the time to event distribution over the time to the next event. And then we use that model to ask, what's the probability of this user coming back in 30 days? That model is at least always going to be as good on the first question. What's the probability of user showing up on 30 days? So it's sort of you get the free...
It's a proxy objective in some way
that
is useful. And then what type of recurrent network did you use? LSTMs, GRUs? Or?
Yeah, they just plain LSTM. My
LSTM.
Long short-term memory networks. Yeah.
It was hot. Yeah, it was really hot then because we have sequence problems. I wanted to use an LSTM. Later, when I've used this in other contexts, I've started to use CNNs more because you can control
one-dimensional CNNs.
Yeah, causal dilated convolutional. So you have causality
convolutions.
Because you want causality.
And perhaps we should explain this. So what the dilated convolution nodes is. How would you describe that?
I think you have probably worked more with speech. I haven't done that. But dilation, that is, you have one layer which is, I think, so dilation is that you sort of, a CNN is a moving window. The steps between the steps between every point that you look at, that's dilation, right?
I mean, I think you can explain it simpler. I mean, normally CNN is just a filter that looks at X number of time steps that are next to each other. Dilation, you basically skip every second or every third or something. And you have dilation between the filters and what you look at. So it has a bigger receptive field. Right?
Bigger receptive field, that's the trick.
Yeah. And it's very common in speech analysis, for example.
And
WaveNet
why do you want to? Why is dilation? Do you have a bigger receptive field? So
you can have a longer time interval that you can get data from. So you can understand from not 3 data points or time events, not 5, but even longer. So the bigger dilations you have, the longer time period back you can look at, basically.
Okay. So you have then a broader sample, so to speak.
Yeah. Cool. And what happened then? You did the thesis work, and what's next?
So I did my thesis. I did go long over time because I had so much fun, and then I finally submitted it. But in the meantime, I sort of wrote a little blog post about it, and posted that, and from that I got a lot of interest in. First, it got me to start a open source project. And that spawned some leads to start working as a consultant, which I did for about 6 months first, and then and then Lars Love Sjösund he knows a lot about Korea, so of course he's following TensorFlow Korea Facebook group. And what I was doing then, I was really just working as a consultant to finance, because I felt like I hadn't explored this topic that I was working on, which was really loss functions for survival analysis. So I was playing around with that. But then Lars Love Sjösund told me that there's a camp in Korea where you go to an island for a month. You're sponsored by TensorFlow. You get free GPU credits, and you're going to sit with a bunch of people and work on your open source project or whatever project you want to have with mentors. So, of course, I jumped on that opportunity.
Super cool.
And
that was was it for a company as well, or was it?
So it was TensorFlow ML Jeju camp. So there's a company called Kakao in Korea, which is, I don't know, it's basically WhatsApp. That's how they started, and they are very big into machine learning. So I don't know why they had this extremely fancy office in the middle of an island, in the middle of nowhere, really.
Bond villain stuff.
Yeah, it really felt like it, but no one was there. So we were allowed to live on this campus. And
so you randomly an island out in the Korean archipelago, so I think. And this is like Bond villain stuff. You go there as a camp, it's a beautiful big building, and it's deserted, so you can use it as a AI hackathon, as an AI hackathon.
Yeah,
amazing.
That was amazing.
And how sounds like Ex Machina in some way.
Yeah, but and people from all over the world, I guess, from all, how did you apply? Was it hard to get in? Was there a selection process? My head is bubbling.
So, because we were looking into the selection process was that they had a big pool of machine learning people from Korea that were signed up as mentors, and then they looked at the applications and decided, do I want to help on this project?
Okay, so good match.
Yeah. And then if we're assigned to a mentor, you got to go to the camp.
So basically you then pitched what you wanted to work on, exactly. And then you were hoping that one of the mentors liked to work on the same topic.
Yeah. And I had this pretty poor understanding of programming, and I needed help to, take this idea that I have in my head and in my thesis, help me make this into a pip installable Python project, which seemed like super hard at the time. Really incomprehensible. I didn't know how I would start.
And this is because of what your skills are and where your skills are not, and now you have moved on. But then this was still, programming was hard. You told us when you started into this.
Writing the code, a little more easy, but installing Python, that's hard still. Packaging things, that's still hard. Having the proper setup to distribute the code and dependency management and similar things, that is still hard.
And why is it hard?
People not using Docker. Sorry.
No, but hardcore. Why is this hard? Is it because you need to understand truly how the computer works and how the environment works, or why is this hard?
I'm now trying to think of it as from now because maybe a lot of the people that are working on this know how to do it. That's one of the main reasons. Now I don't find it hard.
When you know how to do it, yeah.
Right. Now I find it really, I can't even imagine how it could be that hard. But I also remember how it was, spending 2 years of my life installing Python. That was hard.
Yeah. But please, humor me a little bit here. So what, are there many steps, or is it like...
every computer has different versions of whatever, and then a different hardware, and then it's something crashes, so you follow some instructions in how to install some package, and it breaks.
A lot of trial and error, it seems like.
It's so many dependencies that you have that are different every time you try it, and therefore it breaks a lot. And that's why, having Docker and this kind of tools to package things is an awesome thing. It helps a lot.
Yeah, so now it's also the technology moved on, that there have become now different, what we can use as tools to do stuff like this for us has improved, and the APIs has improved and everything, I guess.
It's in the Python world, I think package management has improved a lot. And I think that the people that made UPython and Conda have probably helped,
They contributed
a lot. And it's very simple things that they contributed to, just making that you don't need to be an absolute expert and understand that, of course, your compiler version is not linking to the right BLAS library, so you can't install this and
CUDA
that.
and whatnot.
But could I argue a little bit, like in one way it's not hard, but in one way this is all down to experience, that you've been in all these situations and cracked, butted your head against it, figured it out, and is this what I needed to do? And then this is that type of skill, which is very much experience based. Would that be?
Yeah, partly yes, but also that simply the level of maturity when it comes to some frameworks is really poor. And anyway, cool. So you went to this camp, and what happened next?
So I was there. I learned a lot of stuff, and it was really cool because it was a special time, 2017. A lot of money flowing into deep learning, a lot of hopes. So there was a lot of people there. There was people that were, it was a lot of hiring going on. In the end, the guy that ran the camp got a top job at Kakao's competitor, Naver.
Right.
And he asked me...
What does Naver do? I think everyone actually knows this company, or at least one of their products, right?
Do they? I wonder if anyone... I don't know. So they have Naver.
They do Lime, right?
Lime.
Everyone knows Lime.
Do people know... Do they know Lime? Do they make Lime? I had no idea about that.
think so. I may be wrong, but I think so at least.
I have to double check that because they are. We're googling it. Yeah. So they do everything. They have a lot of blog. It's very similar to Yahoo, but very successful. They have a messenger app, which is very successful. They have a search engine. They have a blog site, and then they have a lot of machine learning. They started hiring hundreds of deep learning experts. And one of those teams, which I started in, was called Clova, which was they were trying to do as DeepMind, but in Korea.
In DeepMind in Korea. In Korea.
So it was focusing on research, and I was going there for what's called a residency program. So I could continue working on the same question again.
And you lived in Seoul, or where is it?
So I moved to Seoul,
yeah,
and stayed there mostly at the office because it was so much fun. 100 people, everybody super excited about this new field, and we had maybe 200 GPUs at the ready. And if you stayed after 11, you had 200 GPUs on your own because we had them physically.
This is hacker stuff at work.
It was fun. And we focused mainly on publishing an extension of my master thesis, which was, let's make this general. Let's.
So you kept working on your core idea.
Exactly.
Wow.
So Churn was long gone. We focus now on event modeling in general, because it was very clear from the beginning. A few people were interested in Churn, but a lot of people that were downloading the package and using it and asking questions about it, it ended up being like people working on cancer research because you want to predict when people will die. People working on HR because you want to predict when employers churn.
So you saw the generic fundamental problem is everywhere, so let's make it generic.
Yeah. And I was interested in the math, so I wanted to make it more generic for not a single distribution, and I wanted to make it even more scalable and see how big can I scale this.
But this is a very cool thesis that it gets legs now.
It got a lot of legs, and we worked on it. I think we did I really thought we made a good paper. We submitted it to ICMLR. And it was completely rejected.
But
we can go down that rabbit hole.
So did you agree with any of the reviewers' comments on that?
No.
They're bullshit.
No, it was reasonable, but I think my fundamental critique was really that. Okay, so my argument was solving this problem. We already know how to. Solving time to event. We already know how to do this. We just take a loss function, as we already have been doing for years. We take this particular loss function with a small little edit on it. Then we use whatever neural network we want. This is just a problem setup, loss function, simple. But then, the questions comes to, did you compare this with framework X, which is using and then they have...
It was iClear, right? iClear. Yeah.
It was actually ICML.
ICML?
ICML. Okay. And it's not ICMLR, it's ICML.
ICML, yeah, of course. But that's one of the toughest conferences to get into. So, you chose the hardest one, basically. So.
Yeah, and it was my first paper. So, I'm not a PhD student, and I was... barely a master student, so who knows?
Yeah, okay, cool. But you didn't submit it somewhere else afterwards, or?
I don't remember if we submitted to somewhere else. I got back from Korea. There's time zone differences. I was working on it with excellent people, but they already moved on. So I just haven't. I thought I'm going to submit it to the next conference, but then life happened.
I've heard that so many other people, I just can submit it to NeurEPS or iClear or ICML, Ishka. And then, are you stupid? The first paper is no way you can get into those kind of conferences. Anyway, fun stuff. Okay, and you stayed in Korea for some time in Naver, right?
Yeah.
And then you got back to Stockholm or Sweden. So
Yeah.
How did that happen?
So it was a timed residency program. So and I wanted to get back because I'd worked as I'd worked now a little bit with research. I've worked as a consultant, and being a consultant in machine learning entails a lot of proof of concepts. And there's a lot of ideas out, and many projects involves, show me that we can do this. To which my argument is usually, well, you need, the whole. There's going to be value in this, but the value is that because in order to do this, you will need a whole data team, and you need to understand the data. And in order to run this, you probably also need people that understand the data and the infrastructure to run this. And the side effect of that is that you're going to have, a data infrastructure. You're going to have people that can do analytics for you, but this is going to cost a lot to do.
And this is the classical angle of the prototype graveyard, that you go in and you do a POC and it can never survive because they haven't understood the full topic. And then we go in the other direction. When we've done this prototype, it's still only 10% of what you need and all that. So how useful are POCs in reality? How, what are you really getting out of a POC? I know you like to prove value first to get going. And there's value to that. There's merit to that argument, but to prove and fail fast.
Yes.
But the problem is, in my opinion, is not that you do a fail fast approach. The problem is that you haven't set up a trajectory where basically we are going down a funnel for a unicorn idea now, and we fail fast with the POC. The problem is we define the POC as the game, right? And then they haven't really thought clearly what happens.
I think the problem is they don't understand the level of difficulty between creating a POC and actually doing a full product, right? And what you need, the extent, and it's 10x, or if not more, amount of work to actually have a deployable product compared to building a POC. Would you agree?
Yeah. I just haven't seen many, because I've been working on this boring data structure, which is, tabular data, etc. I haven't seen a lot of cases where it's feasible to make a POC that would have anything to do with how hard it would be to do it in production. It's because the last 10 steps to do it, that's going to shape how you solve the problem and the meaningfulness of solving the problem.
But it's also, I think, if we take churn prediction, which is your specialty, it's more like a BI kind of problem, right?
Yeah.
So you don't need to have it perhaps in the full production setting in that way. It's useful if you potentially can have some. Is it weekly report, or how do you normally use this kind of churn models?
So first off, I haven't deployed churn models. I did it. I've been doing it. We did it at Ticktail. We deployed a churn model, and then I've been working on problems relating to this problem.
Right.
But what I've seen from people deploying, it's you want to predict maybe daily. So daily you would predict what's the likelihood that a user will return and do something in 30 days. And then you just use that score to sort users and then pick the top.
Because you want to trigger someone for a customer service center or for a customer success manager to which one do we need to act on in order to mitigate churn, more or less, right? So it becomes not only an insight, it becomes a trigger for something else to happen, I guess. Yeah. That's how you deploy it.
Yeah. So ranking, that's one. That's the easiest. That's what I recommend people start with. Always, whatever problem you have, rank. Because if you can do anything where you just by sorting a list, you find value out of it, then it's very easy. The next thing is if you want to take a decision on it. Because then you need to find a threshold, and then suddenly it starts getting pretty much harder to see that what you did in production or in your experiments match with what you are actually going to do? Do we want to send out, 1 billion emails here?
I remember some discussions from years back, but we also did some churn prediction, and we wanted to find an action, and an action can be to send an email saying, look at these awesome things, or you get a free discount if you go back and do this now. But the actual act of sending an email can actually trigger them to churn faster because they get annoyed with getting emails and they don't want to get spam, right? So this is a very tricky, I think, problem to know,
what is the next best action when you have a churn prediction? Yeah, not easy. But I like that simple tip. When you get started, you find a lot of usefulness out of ranking. So basically you're getting whatever your actions or your resources to focus and pay attention where it matters most. Ranking is all you need.
Ranking, yes.
That you come a far way with that. And then you start from the top, and then your day is finished and you got to number 5 or number 6. Who cares?
And there's...
bottom line, I guess.
And another thing is that as a data science problem, it's so much easier to evaluate because we have metrics like area under the curve, which the only dependency that you need to have on your prediction is that you can rank it. And that may sound like a low constraint, but it's really helpful because if you want to do things like, take a specific decision, for example, if predicted value is above 7.0, then there's a lot of more things that can go wrong. It also needs you also need to make sure that you don't have duplicate entries in the data or whatever that makes the data calibrated. And there's so many different ways to evaluate that, and you need to understand the problem so well to start doing that. And then we haven't even started if you want to make a decision on a probability. So you want to do something where you take a human decision, like, okay, want to predict what's the probability that the user will do something. 30%, what do we divide by here? 30% out of all users, 30% for this particular user and who's are included is a user that hasn't been active in 4-5 years. Are they included in this probability? Like it's
a minefield.
It's a minefield
when you start opening up. So basically what you're saying, for a very pragmatic approach, ranking, you get a lot of value. You get a lot of bang for your buck.
Yes.
For this was quite simple, and we got usefulness out of this. To take it here, boom, you open up Pandora's box. The minefield comes now, and you kind of need to navigate all that in order to do it really well.
Yeah.
Cool. The time is flying away, and I'm trying to push a bit forward as well. We will not want to do more than 1 hour of background stuff, but I guess the next step is the main topic also in some way. You got in contact with the Schibsted somehow.
Oh, yeah.
How did that happen?
So, the contact happened, I think it could be thanks to you. It was a couple of things. So it started with, I had no idea about Schibsted doing anything cool until they organized a meetup. And I think you and maybe Atalach was on doing this. Could that be?
Yeah. What year was this approximately?
This could have been 2016, 2017 or something.
Maybe.
So there was, could have been 2016, because there was a meetup where they presented a bunch of cool stuff that they did, doing...
I think I recall that.
Doing anything from transfer learning on text and images of Blocket ads and similar. So that made me realize that Schibsted is a good player to look for. And then I found an ad on Stockholm AI website, because they have a job board, which I can really recommend. I don't know how much it's updated. It's usually something that this is done completely manual. And if you send anything to post my ad here, someone will probably manually add it. But it's a place that is a good place to look because it's very specific, a very small crowd. Yeah. So that's how I found it.
Some of the best AI people, I think, in Stockholm at least.
Hope so.
Yeah. Cool. So you replied to an ad then, or?
Yeah, I was looking at a lot of jobs. So the basic idea, I came home, I've been doing a lot of consulting. I wanted to go from, a hunter-gatherer that's doing POCs to, a gardener that is, because I really wanted to learn how can we build and manage big machine learning systems and see them, from the start and live with them.
See them actually make some use as well.
Yes.
Right.
Production.
Production.
And improving in production.
The whole thing, which seemed very interesting to me back then.
And perhaps we should move to the topic about, for people that don't know Schibsted. I think all of them know the actual companies they have, but they haven't perhaps heard the Schibsted as a name that well. How would you describe what Schibsted is?
We're a... I don't know if we call ourselves a media company anymore, but we are a big company that is an ecosystem of brands. So we have a lot of classical publishers. In Sweden we have Aftonbladet, Svenska Dagbladet, and probably more. And then we are big on classifieds. So companies like Blocket and in Norway, Finn. And up until recently we cloned Blocket to the rest of the world, which is now been spinned off as its own company. So there's Blocket variants all over the world right now.
Yeah. But there is one in Russia as well, if I remember. But that was not owned by you, I think. I think someone copied it without your knowledge in some way and launched.
Oh, I do not know about this. But there's these classified sites all over the place, which is pretty interesting.
But they actually have exactly the same type of map on the front page, and it's clearly copied. And it's fun to see.
That's interesting. I didn't know that.
Yeah, but actually, but the way Blocket did it anyway within Schibsted is basically successful, proven Blocket and Finn, and then now we go to France. And we do the France version of Blocket, and then the base code is the same, or is this a branch off of the original code, or is it?
I don't know if I've been fortunate enough. I haven't worked on that. This was actually just before I started. All of this happened, but it was, an explosion of different companies going all over the world. So that was an interesting. We had offices everywhere.
And how is it organized? You have all these brands now, but you can also think about some kind of centralized part, and then how much of AI and data engineering is happening in the brands and how much in the centralized organization?
So I've been part of the central organization all the time. So and I think almost all of our brands has data scientists. So most things that happen in Schibsted are happening on the brands, almost all of it.
What do you mean? The most work is being done in the brands itself, not in the centralized part?
Yes.
Okay.
So, all the companies have brilliant data scientists working on their own problems, but then we solve a subset of problems centrally. And we're also focusing on, making it easier for the brands to get value from their data.
So this week is going to be interesting around the infrastructure. Have you been able to find like a distributed architecture or something like that allows everybody in Schibsted to be their brand and their domain, but then reuse infra self-service? Is that what you talk? Do you have a shared infra, or how does that work?
We try different ways. We've been trying different ways and different setups. And that has worked with varying success.
So sometimes, if I take one brand, Aftonbladet, they might have their own stack fully, and then, or everybody has a subset of Schibsted, or is it very, the legacy there's a story in each of these brands, I guess.
So the nice part of being a Schibsted is, we have a central team that will help you with IT, help you with setting up things like that, and then we can have if Aftonbladet would want to set up a Kubernetes cluster, then we have experts that can do that. Then we have experts handling deals with cloud compute and security. So there's resources all the time to help brands.
But would you? This is very interesting. Would you argue that this is sort of a servant organization in the Schibsted organization, and the brands come and get for it? I mean, like I've seen this in different companies, how you try to push out the central IT organization in some. This is some ways, and other ones like no, our brands are too strong. We can't tell them what to do. We can just only serve them. How would you frame the Schibsted relationship to the brands?
I actually do not know. And I wouldn't be the best person to say because I'm in the central organization as well.
Yeah. So if let's zoom in on your part. Do you get sort of problems to work on, or how does it work? What do you do?
So I work in an organization where we have a lot of media companies. So then the question is, how do we do tracking? We built our own tracking in-house, and that gives us a lot of control over privacy and over how we distribute data and how we can deal with the data. And that we also do our own targeting solutions, which is helping us minimize how much data get exposed to third parties. And I'm working on that. So I get click events from all brands, almost all brands. And then we build models to extract and infer different properties and that we can use for targeting and use for analytics and services as well.
When you say targeting, is it for ads?
Yes.
Yeah. And can you just describe more for people not into the whole ad business? So you get click events, and in some way you want to target ads. Do you do segmentation, or what type of work do you do to do the targeting?
So it could be easy things. Maybe we want to target on people that has been interested in sports, for example. Then you need to get tracking data for who has visited sites that we have tagged with sport.
Right. Sites or pages in Aftonbladet or what? Or?
Yeah. And aggregate that data across different sites.
Right.
And that may sound like something that is very easy, but then you suddenly end up with a lot of companies, and then we have different countries. So, and as I said, we want to, we're very careful how we collect and aggregate data across different controllers, countries. And then you also have the privacy concerns that we only use 30 days of data.
Oh, interesting.
Which is, I don't think a lot of people know this, but what happened is only will only be leading to targeting for 30 days.
And you don't aggregate in any way. If you want to have yearly kind of patterns in some way, you must have some aggregated data at least.
So aggregation, then we're an analytics purposes. That's a different thing.
Yeah. Okay. But operational data is kept for 30 days, basically.
We build our models based on that.
Yeah.
So the causality between what you do and what you're targeted on is based on 30 days of data. It's actually less than that, but that's
that's mainly for privacy purposes. Or?
That's only for privacy purposes.
Yeah, from a data science point of view, you want to have as much as you can, I guess. But yeah, nice.
I mean, it's really nice that you're taking this seriously and you're finding ways to work with it, because it's just it becomes ridiculous when you don't do anything either, right? So finding a good balance and finding how to do it, which is relevant, and I think it's good, really good.
I'm not sure how much you're allowed to say about this, but can you mention some of the tech stack you're using in the centralized department to do the tracking? And are you using some cloud, or are you using some special services there? Or can you mention
I don't know much about tracking. I can't say much about the tracking itself, but I can say a lot about what we do when an event from a device is sent and we can build models on it.
Yeah, please.
So we get this, billions of events.
And it's billions per day or per what?
Billions per day, I think. Yeah. And that's basically you can consider it as a JSON. But then we munch that into Parquet format, and we aggregate it. So,
and just for people's curiosity, Parquet is this kind of column-based, big data format.
Yeah,
it's one of the popular ones, right? And you save it on some. Do you use on-premise or on the cloud?
No, we use the cloud. So we're using S3.
S3 buckets.
AWS S3 buckets.
AWS S3 buckets.
Yeah.
So, my world can be seen as, okay, so now a new hour of data has been rolling in.
Right.
And now my Luigi jobs needs to have a look at, is this hour complete? And Luigi is just looking at the dependencies, and then a whole lot of jobs are going to start aggregating data and building predictions.
And perhaps we should mention Luigi is actually an open source product from Spotify as well.
Right.
Yeah.
And it actually had two purposes. One was to run on Hadoop, which no one is using anymore, but the other part is the scheduling part, and trying to make sure that you have every day the data you need, and they can track the dependencies. So if some data set is dependent on another, they will start running that job, and if that is depending on something else, they will start running that as well.
Yeah,
and stuff like that.
Did you ever work with, what's his name?
Egil Martinsson.
Yes,
of course. Also he and another person, Anders Nyström. He was on the show as well.
Yeah, Anders was on the show. Anders Nyström.
They were the two actually that created Luigi as well in the beginning.
They built it even, right? They were really as an open source for their own purposes to figure.
Yeah, in the beginning, yeah, but then it scaled.
Then it got legs.
Yes. And cool. Also, that's awesome. So I think Twitter uses Luigi and so many others. So it's kind of cool to see.
There's so much and so little happening in that space. I've seen so many new projects that seem to be trying to solve the problems that Luigi is trying to solve, which to me it really looks like a Luigi clone. Like digging really deep into Luigi, in the end, I feel like a lot of the stuff that I've been having pains with from Luigi is problems that I created by not understanding Luigi.
I think a lot of complaints in Luigi has been they use a lot of Python magics that's happened underneath that's seen. So it's not like really, you get surprised that stuff happens without explicitly writing code for it in some way. That's
I need to look for that, because maybe that's
magic.
I mean, magic is a bad thing, I think. In the world of programming, magic is bad.
This piece, scheduling, you want to be in control.
I mean, there are a lot of these kind of things you can do that triggers without you actually writing code for it. And the code looks nice because it's very short and brief, but in reality, you don't understand what happens underneath. So it's better to be explicit, I think, than implicit in that sense.
And when you say happens underneath, what does that mean? Like if the code is right, but it's calling on something else.
Yeah, I mean, there have these kind of double underscore or double underscore methods in Python that get called, without you knowing it sometimes. And these can be abused, I think, to an extent that makes it hard to understand what's
hard
really
to follow what actually happened.
Yeah, so it's magical. It happens without you knowing it in some way.
So, but if you know deeply how Luigi is built, you would know this.
Yes.
But then you're really deep into it.
Yeah.
Can you go and have a look in that? You can go to the Python.
Is open source. Yeah.
That's the good part. But then again, it's also the thing. Whenever you want things to happen concurrently at the same time, there will be magic, because you can't really follow the logic linearly.
No, the parallelism looks magic to the sequential human brain.
Yeah, and I think that could be, so our setup, we have hours of data, so now we have new hour data. Then Luigi is going to look for, did the aggregated events per hour complete, and did the aggregation per day complete? And if they did, now we're launching a Spark job. If they didn't, now we're launching a Spark job to aggregate that data. Mm. And there's going to be one Spark job for Finland, one for Sweden, one for Norway. And this was just, one stage. Maybe we have 20 pipelines or so, 3 countries, and we have a dev, pre, and pro environment. Yeah. And then maybe we're aggregating in other dimensions. So we will definitely aggregate per hour, day, and then per look back, which is, now we want to aggregate on the past 25 days of data. Suddenly we have a lot of stuff happening, because the aggregation, that's going to be run by Spark. And a Spark, that's now one machine that is going to launch a bunch of different machines, executors. So you can just imagine the scales of things that to keep track on.
Do you know how many machines are used to run all the pipelines you have daily? Like an average number of machines that is being used?
I should know this. No, I don't. I actually don't know. We did publish a blog post to my colleagues. Maria and Nils tried to do a carbon dioxide, CO2 estimate on what one of our deep learning pipelines cost. And it's quite a lot, actually. It's more than you expect. Compute is expensive.
Yes. Cool. Okay, so you have the tech stack there. You use Luigi to schedule the jobs. You have Parquet to save the data that comes in as well. You use Spark to do the data processing as well. Anything else you can mention besides that?
Yeah, this is running on Kubernetes.
Yeah, and even the Spark jobs. Are you running Spark on top of Kubernetes? Oh, yeah.
Spark on Kubernetes. So we moved out from we had this enormous, many terabytes of RAM at a given time system where we everybody in different brands of Schibsted would submit jobs into. In the end, we didn't understand. No one of us understood how it worked. So we sort of, there's always this move from central org to distributed tech, and Kubernetes was one of these moves where we, every brand needs to control their AWS. They need to control or at least in our little team, like our team wanted to control what we did. We want to control the infrastructure. So that's how we moved to Kubernetes. And now we're running everything on it. So we run services, we run batch jobs, and yes, we run Spark as well.
But you have a separate Kubernetes cluster then for Spark and another one for
No, it's picking the same resources.
Oh, interesting.
And elaborate and explain a little bit to me. What's the beauty of why we start moving more and more stuff to Kubernetes? Kubernetes.
Yes, Kubernetes.
I think the jury is out on that. I mean, I find it.
I'm asking honestly, like a business person. Yes. We heard this Kubernetes this and Kubernetes that. From the horse's mouth, the people working on it. How do you feel? What's the simple truth to package? Or
to me, it's like now, whatever I'm forced to at least imagine that I understand the whole the whole idea of how I can run a program in a container. That forces a good habit that you have to containerize it. It forces you to understand, and for other people to look at what you're running. You can share compute resources between jobs.
So containerization in itself leads to many useful habits. You're thinking about this. You're productifying with your stuff. It forces you to think in a scalable way, maybe.
Yeah.
Or reusable way.
Yeah. And I mean, I don't know what our reasoning has been about it, but for all of the use cases people can find, like, okay, so I just want to run this little function. Yeah, you can run. There's AWS Lambda for that. We want to run this service. Yeah, there's
serverless.
There's probably some serverless solution for this. And then you want to run batch job. Yeah, you have AWS EMR cluster. But now you suddenly have 5 things to think about. Yeah, right. And thinking about even one thing is hard enough.
So your argument here is a little bit like potentially you can solve this within the AWS world in 3 or 4 or 5 different ways by grooming everybody. Look, we like Kubernetes, we do it in this way. All of a sudden you start building Lego that starts fitting together better, I guess. Yeah. Unless to think about 5 different variations of how to do things. That's more to maintain, or more maintain variability or something like this.
I think that's at least what I find very valuable to it. Having to run these things, like a big resource is mental, like having a reasonable mental model. The mental model can be bad, but if it's at least a model, you can work with it.
And if we were to go, sorry for going a bit more techy here.
No, this is what I wanted actually.
So there are different ways to just administrate all the Kubernetes ways. You can do the core, like the YAML hell of all the different ways you define the resources on Kubernetes, or you can use Helm charts or stuff like that. How do you admin just orchestrate all the Kubernetes resources?
We have been. Recently, we were, one team. We were maybe 10, 15 people. Some people were keeping control of that. Now we moved that into more of a central in our little org, a central infrastructure team. But then that's after it's already built and tested. So they're keeping track of it. And then all of us machine learning engineers, sometimes we fiddle with them as well. But it is sort of a specialist.
Have you ever suffered from the hell of all the YAML files that otherwise is normally used to just administrate or configure the Kubernetes cluster?
Oh, yeah. But fortunately, I'm not bearing the burden of that. I'm probably just getting the effects of it.
I think this actually moves nicely into the next topic, which is really what your role, an ML engineer, is really about. And perhaps we could just try to describe, the different type of roles that you do have in Schibsted. And then you have some people that are, focus more on the infrastructure side of things, like administrating Kubernetes. What are they called?
We usually call them maybe data engineers.
Yeah.
It feels like we're in the twilight right now in terms of what roles people should be using. It feels like a data engineer is a position that, I don't know if it's back-end engineers or...
Data engineers, I was sitting here guessing what were you going to answer, and I was like, surely that must be data engineers. But we all come from different legacy and where we have started, and we've called it different things. I remember when everybody was data scientists, right? There was no differentiation between this, which I think, to some degree is useful there is a distinct difference between data engineer, I would argue.
Yeah, and I think some people would argue that data engineers does not, configure Kubernetes either. That's something that an infrastructure engineer would do.
Now you can hear the level of sophistication here.
It's also similar to a topic we had once before. We can see an increase in specialization in different roles that we have. And it's so many different tools and services and things you need to know. So it's super hard for someone to know, how do I fix the Spark jobs? That could be the engineer part. Or how do I train a model? Well, that could be the ML engineer, potentially the data scientist job. Or it can be how to orchestrate the Kubernetes thing. Or it could be how to do the ML ops and monitor all the things that happens there. And that could be another ML ops position.
It becomes super complex now for anyone to sort of be the we're looking for a full stack engineer.
Okay.
You know what I mean?
Yes.
It is hard.
It is hard.
It is very hard to hire.
But basically, data engineering as one broad understanding for Spark and Kubernetes, Luigi, Parquet.
Yeah, and the differentiation between, I think my mental model of this is basically like, maybe a machine learning engineer is a bit more experienced back-end developer than a data scientist. Maybe a machine learning engineer is a more experienced, more full stack than a data scientist. Maybe a data engineer is more full stack than a machine learning engineer. But maybe that's why we have tended to start using and when we hire for machine learning engineer, because when you hire data scientist right now, it could be anything from, someone that is doing analytics in Google, or someone that is doing, big data in Scala. And we have been hiring, at least for our team, that someone's that want to do big data analytics in Spark, but also really good at TensorFlow, which is, maybe we need to reevaluate that because it's very hard.
But I think this is super interesting. You can go first. They're opening up
you mentioned
rabbit hole.
Is that the main framework you're using, or are you using PyTorch as well, or is it the full TensorFlow?
We moved into TensorFlow. So we have been running a bunch of pipelines where everything was in Spark.
From Spark to TensorFlow then.
Yeah.
Okay.
So we've been Spark people, and we've really been very heavy on Scala shop. But then again, people, especially the scientists, tend to like Python. It's very few people can get productive fast with Spark or Spark or Scala. It's immensely complex Spark. If you really want to optimize it, I wouldn't.
So could you? What are we talking about here? So Python. What is, in your opinion, or in Schibsted, what is Python? What is Python used for versus when Scala and Spark is still used?
So in our team, we have tried to do it as we try to do aggregations, data engineering. Aggregations and moving data from one point to the other, that's Spark. But then the modeling part we're trying to do it in Python and TensorFlow.
Simply to use libraries and stuff like that, or why?
To make it possible for data scientists to actually do anything with it.
Okay, because when you ask them to do the same stuff, but you're framing them, you can do whatever you want in data science as long as you do it in Spark or Scala. Then the number of people who can do that is very few.
Yeah, and the joy of doing it is also maybe less for a lot of people. And the number of frameworks that you are allowed to do. Yeah. So if you want to do if you want to do deep learning, I'm sure there is some way to do it in Scala.
Yeah, but here you have TensorFlow. You have these libraries where as you always say, no professional ML engineer would start any project from scratch today.
No, for sure.
And
I mean, they don't understand, as you said, how the level of difficulty and complexity that Spark has, for example, is extreme, and the same could be said for TensorFlow.
Yes,
it's not even a consideration. You can build potentially in scratch, simple perceptron in Python without using TensorFlow, but as soon as you scale out in any way and want to use it seriously, it's impossible, right? To not use it.
Yeah, and it's hard enough to do it in TensorFlow.
Yeah, exactly.
It's a framework that has been growing out of proportions, in my opinion. I think my home is in PyTorch.
Yeah.
But I also really like the graph model of TensorFlow.
What do you think about the future then? I mean, PyTorch has been growing a lot, especially in the academic sense, and it is much nicer from building POCs and prototypes is easier in PyTorch, but then you can argue potentially if you want to put the stuff in production, then TensorFlow has some better libraries and support for that potentially. Would you agree? Or
they have a lot of more communication about that they are good for production. And I fell for that. I must agree. I completely
You are not convinced that TensorFlow is better than PyTorch, in your opinion? I mean, being, your own. I
haven't worked with I was working a lot with PyTorch before, but I haven't worked on it maybe 2 years, since 0.4. And I've seen that PyTorch has been maybe falling into the same traps as the same time as TensorFlow has been trying to grow out of. So the trap is basically you want to build a computational graph, which means that it's something that you can compile, which it supposedly is supposed to speed things up. The effect of that in TensorFlow was that it's impossible to debug. PyTorch got popular because they were doing the opposite. Let's just do pure Python code. You can track every line, you can debug it, you understand what's going on. There's no magic. But then they sort of at 0.45 realized that we could probably earn some speed here by adding a compiler.
Now people don't know what's happening anymore to the code.
No, I at least I can't go into the repo and really trace it. So that limits the amount of open source contributors that can do. But at the same time, TensorFlow learned that, okay, no one wants to use this. We can't debug. So they moved into what is it called?
Eager execution.
Eager execution. And now me, who is trying to run graphs, do not understand when it's running eager. So it's in my opinion, it's sort of, maybe you just need to restart the framework from scratch every 2 years or something when you learn things. And I guess that's what happened with, what's this new
JAX, or no?
JAX, yeah. No, not JAX. The one that Google now uses in secret internally. It's one of these pure, more NumPy-like libraries.
Oh yeah. I don't recall the name of it. Sorry,
the scoop going on right now.
But JAX is also one of the things.
So what is JAX? This is evolution. So people who's been down in these rabbit holes too long, they say, wipe it and start in a new direction. Or what are we talking about?
Yeah, but I think everyone is realizing that TensorFlow is hard to debug and hard to understand. And we also want to use the simplicity of NumPy, for example, and SciPy and these other standardized libraries that Python has. And they want to copy also PyTorch, I think, and it's so nice with the tape structure they have in PyTorch. It can simply do auto-diff or auto-differentiation, with the code you have. You just write the Python code with a for loop, and it can understand that. And that is, I think, something that now they try to do in TensorFlow. It does, partly understand it or work with it, but not fully. But JAX can do that with AutoGrad and also do this kind of XLA compilation. So it compiles in an automatic way.
Is it taking traction, or is it in like some large? Is it like Google using JAX and that's it?
Yeah,
or?
No. It's certainly a popular one. I think it's still mainly used for research purposes, but I don't know really. But I think they're trying to copy each other. PyTorch is going the TensorFlow way, and TensorFlow is going the PyTorch way.
They're looking at each other.
It's a lot of the same people as well. Like it's not. I don't think it's a competition really. I'm not sure.
And can I ask you both? Do we consider these as open source?
Yeah, why not?
No, let's be cynical now. Who is behind TensorFlow?
But of course, but Google had, the internal product. What was the name of the internal project before they released TensorFlow? Oh shit, I forgot the name of it. That they had internal project, but I think most of the project they have released in Google as open source has been internal projects, and then they call it something else, and then it becomes like TensorFlow, and then they release it. So it is open source in that sense, but of course Google is behind 60-70% of the commits, I guess. I don't know. I don't have exact numbers for it.
And humor me now as a very stupid question. I mean, like in the old, like I'll take another example, and you help me out if there is an equivalent. If I say Linux and we go Linux, then we start getting sort of enterprise packages around Linux, like Red Hat. Do we have those? Is that existing in the TensorFlow PyTorch world, or is it more pure open source?
There's a lot of plugins and packages above TensorFlow that is commercial as well, of course.
I don't know how much they are used, though.
Exactly.
But in Google, for example, they have the whole, in the Google Cloud, the whole, it was called TFX before, now it's called V something, whatever. But they have these kind of services that they pay, you have to pay for to just make it, more easily accessible and easy to use.
Yeah, so they add
it on top of TensorFlow.
Yeah, so this is what this is what I was asking for, because it's like the same in with Kubernetes. You can run native Kubernetes, or you can run Azure or AWS version of it as part of their service, right?
They all have their own native Kubernetes versions.
Yeah, and now in TensorFlow, I guess it's the same. Could you get to the TensorFlow library? Because Kubernetes, we know they have a native versus the AWS approach, right? Yeah. And how is it in TensorFlow is my question. Is it equivalent that you have a...
I think basically, I mean...
You can run it as a service.
It's a basic library, but then they have commercial services built on top of it, I guess.
GCP
has it as an example, right?
I'm kind of skeptical. Yeah, and that is, you never know what is actually meaningful.
Yeah, is it meaningful to use their service when it's the same stuff but they put some wrapper on it, or do you really want to rather use native?
I haven't run into really any useful or anything that I've found useful as a machine learning service yet.
Do you rather use the native open source?
Yeah, absolutely. I don't know if that's just a style or a feeling, but yeah, I tend to like open source. I mean, like in the comparison between TensorFlow and Linux is, there's one, Francois Cholet of Keras. I felt like he has been shaping the API a lot, probably for the best. I'm been fighting Keras now for years, just trying to work around the API a lot. But it is one of those projects that it feels like it's run by very few people in the end that's really guiding. And maybe my feeling is that PyTorch has been more transparent, but I don't know. I think it's all good.
Awesome. The time is flying away here as well.
You got your nerdy conversation today,
yes.
Anders.
So thanks for
I was standing by you. I was standing by you, not coping, standing by.
As you mentioned, Francois Cholet, the author and creator of Keras as well, which is now the go-to API in TensorFlow as well. And if we move to definitions of AI, more like societal kind of, different philosophical kind of questions, do you have a preferred definition of AI and intelligence? He actually released a paper in 2019 about intelligence itself. Yeah. But if we start with AI, do you have a preferred definition of what AI is?
I mean, people don't tend to agree with me on this, but okay, so...
Good, I like that.
This is going to be good from the start. I love it.
If you have an if statement and you have some aggregation based on the world, that is like, if the mean temperature is above 3, that's AI in my world.
Ooh, now we have to elaborate more, I think. Okay, can you elaborate?
I mean, maybe it starts based on intelligence. We are moving the goalpost of what intelligence is, but light sensitive bacteria that reacts on external stimuli. I don't really see. It's more of a quantitative question about how many stimuli you can react to.
So it's continuous scale in some way. It can be 0 or it can be 0.01 and it can increase, right?
That's how I see it. So I haven't really, I guess.
So a thermometer that measures the degrees of Celsius, would you call that having intelligence?
Yeah. I mean, okay. It's that's now we're sort of pushing the boundary, but maybe that's because intelligence is a word that we created. It's not, sometimes, maybe it's not, it's a word, right? It doesn't necessarily need to be something that exists.
No. But hopefully it should be a term that is of use in some case. Yeah. I mean, if you say that something is everything, like a system is a term like this. I think the term system is abused a lot. And a system can be anything. And if a term can be anything, it ceases to have a value in some sense. It doesn't really help you by using the term if it means everything. So in that sense, I think it's nice to try to find a useful definition in some way. And I think actually I agree with you so far, but I just want to still push you a bit.
Yeah.
So,
I'm not following right now. This is too difficult for me. But so what is your underlying thought that goes in this direction for the definition? So you're saying a very concrete definition in one way, or a very mathematical definition almost.
I guess it depends also when we want to use the definition. I think I'm going to try to make the argument that there's nothing particularly interesting or surprising about what we're doing now or what we're going to be doing in the future with AI. It's just the quantitative questions about how good we are at it. And it's not either going to be anything particularly different from what bacteria how they would react to light. So
if I'm taking you right, and this is from a philosophical point of view and an attitude to this, we want to demystify and take away the hype and the magic, and then defining something which is actually quite mundane, if I say it like that. Yeah. Then we can be more and more sophisticated. So you're trying to then, from your argument into this philosophical question is, let's find a definition that is actually, not magic. Or is that? Yeah. Do I understand you right?
I don't think there's anything wrong with having a word that sort of incites hype and interest. I think it should be exactly, a fun enough word to incite some hype, but not overpromise and make people scared.
Yeah.
And it feels like we're moving into that place. Like now we're talking about AI all the time. A couple of years ago we talked about machine learning, but in the end we want to use the word AI. So now we're using that, and that's fine by me.
Do you think the term AI has been used more in the recent years than previously? Yeah, I think. Yeah, interesting.
Well, I would agree for sure.
AI has been around since 1950s as well.
Right. So in your bubble.
And I remember...
So old.
In your winter filter.
I didn't read that book really well, but was it like on electricity in Mention and Animals, where they try to define AI as, if we have a machine that can do basic regression as a definition of AI. And I think what by going to this, anything that reacts to external stimuli, we can go to what we're doing now, where we have models that, maybe we don't exactly know, we can't control them as well, but they can do a more wide range of tasks. It's still the same thing. We need to look at it in the same way, and we don't need to be any afraid of how it's working. But we still need to put the same constraints on, how they work as we did with anything we did in the 50s.
But if we go a bit more concrete, if we start with just intelligence then, and we perhaps can just start with François Chollet's definition. And
what is his definition?
Yeah, so in short, it was basically, he said that intelligence is the skill acquisition efficiency. And that means skill can be like playing chess, driving a car, can be predicting if it's a dog in an image or not, or translating text, or whatever task. It's some kind of skill that you have. And the faster you can acquire that skill, the more intelligent you are. So it was really the acquisition of it that is the term, that is the intelligence, is not having the skill. So having the skill is having knowledge, but acquiring the skill is intelligence in some way. I'm paraphrasing a bit, but that in short what he said. What do you think about that? Does that make sense?
It makes me so confused in terms, and aren't we quantifying human intelligence because it's a good predictor for whatever we want to measure it for? I don't know, we're measuring, arguably if you were measuring someone to, are they going to be good at math? Maybe we can potentially see how good they can rotate things in their head. That's a model to predict something else. What is this model to do?
I would say that is more a skill, and it's more about acquiring the skill that's intelligent. So if someone wants to be good at playing tennis, and they have never done it in the past, and you have two people that have the same, like two twins or something, or perhaps not twins, that's a bad example. But anyway, two people that never played tennis before, and both are being trained to play tennis, and one of them can do that double as fast as the other. That potentially means he has bigger motoric intelligence in learning how to play tennis. I think in some sense that makes sense to me, at least. And I think also it's nice to distinguish between intelligence and knowledge. Having the skill to do something is very different from acquiring it. In that sense, would you agree?
Absolutely, and thinking about it like that feels like a good model to, maybe, as we talked about earlier, to try to figure out, can this person learn for the future? But I don't know why I would be interested in seeing, how...
But I think I can move it to AI. Yeah. I have this kind of connection, I think, to this, to move it to AI. And if we take traditional, 50, 60 years ago, when you try to build an intelligent system, AI, you would basically manually program it. You would manually program how to do translation, for example, and you would write all the grammatical rules and whatnot and try to, do that manually. And that was really slow. It was really hard to build in the skill of doing translation. So you have to manually program it. But then suddenly we got machine learning, and it could feed data into the system instead of having to manually encode all the grammatical rules. So suddenly it could much faster and to a much larger scale learn how to do translation. That means that the efficiency of acquiring the skill to do translation was significantly improved. Therefore, intelligence in that system to do translation improved. And then with deep learning, you can also represent the data in a way that you can't otherwise with traditional like machine learning and feature engineering. So that once again improved the efficiency of building the skill to perform translation. Therefore, intelligence improved as well with deep learning in that sense. I think it's kind of a nice analogy, right?
Yeah, I like that.
You've been practicing that a couple of times in your head, but I like it because it's like we use these words, right? And we we have all these different human-like intelligence. We have all these definitions. With artificial intelligence, is when computers feels like humans, and then you can go all the way down to the old test. What's the test?
Turing test.
The Turing test, right? Which is completely not, it's Rogerian commenting, right? Rogerian answers. It's not intelligent at all. It's just programmed to make question you back whatever you're saying, so you feel like it's intelligent because So all these different definitions is sort of, I don't know if they're putting us on the right path. So I kind of like when someone is trying to, could we make it very basic or, like you did right now? I kind of like your argument, and you've been indoctrinating me on this one now. I can almost do it in my sleep soon.
Sorry for that.
But it's good, man, because it's like so easy to say intelligence, right? But how do we define it properly? And this distinction to knowledge, for instance, or skill. So I don't know. Why is it? I flip it. Yes. Why is it important that we have a good definition for artificial intelligence?
Because it's fun to discuss.
No, but there is a couple of reasons why this is super important.
What is that? I actually don't know. I think it's more. Yeah, I don't know actually. I can just tell you a story. I know my old PhD professor. This was 1999 or something. I asked him the question. He was a first professor in AI. Erik Sandevall, by the way, and I asked him the question in the end of 90s, saying, how would you define? You are the most knowledgeable person in AI. How do you define AI? And he replied saying, "Why do you want to know that?" And I said, "Well, I'm going to do research in it. I have to know. You have to have a good definition." I said, "Why? Just speak about other concrete stuff." He didn't think that there is a big purpose of having a perfect definition of AI, actually.
No, and
he didn't think it.
So. He did not think it was it's fun for philosophical purposes, but it's not really a useful thing.
Okay, so I'm not saying this is useful. I'm observing a problem when you have a very unclear definition of AI. And that problem is, for instance, when we now try to regulate AI.
Yes, good point. This is a very good point.
So basically, how the hell will you regulate anything if you can't agree upon what it is? Yeah. So for me, when we talk about ethical AI and we're going down that direction, we need to agree upon some form of definition in order to build a mental model that we can regulate. That to me is quite important.
Yes. And the current definition in the new upcoming AI Act is
interesting.
Interesting. Yes, let's call it that. Have you been into regulation in any way in Schibsted, or is that
Schibsted has been active in this discussion. I'm not very well read into what our position is, but I think our basic position is that this regulation has to be. First, it has to be actionable, and seems like there's too much vagueness in it right now to be actionable. Yeah. And if it's not actionable, it can also, discredit small players.
Yes.
We need to have, some kind of way to encourage small actors to be able to take part of the machine learning space.
This is so in line with what with all the guests and sitting here now for 54 episodes, is sort of the major problems of the AI divide. Now I'm going to take a shot at what I see is the problem and not the problem. Oh, okay. The major problem is not that we have some tech giants moving ahead. The major problem is the tail, which are the small players that are not getting a fair chance to even participate in the future society. So we shouldn't point fingers at the big players. We should applaud them for helping us move mankind forward. But we can't lose the tail end, which is the majority of people, if we want an inclusive world. So we need to work on the AI divide, but with the right objective, with the right focus, which is the tail end, in my opinion. Yeah. Don't worry so much about what they are doing and regulating them. Worrying about regulation in order to be fair, be right, but make sure it's actionable for the little people or for the smaller companies. I think that would really flip it, how you would look at it.
How do you think? Imagine, someone wants to do a startup right now, and they are interested in getting into AI, for example, and we have, a number of things that is challenging for them to get into. It could be the tech problem, of course, of knowing all the stuff, but you can learn that skill. And if you start up, you can do some shortcuts, perhaps. But there is a big problem with the regulation, and the problem, if we just take GDPR and ignore the upcoming, regulation that is on the way, you could see at least from GDPR that they had the intention, which was really good. Of course, we all love the intention of GDPR and preserve privacy, which Schibsted, of course, is very concerned with as well. But then it led to that, it was very easy for the tech giants and the big companies, and Schibsted is a big company as well, so they can actually conform to the regulation that exists.
You have the tech stack to manipulate and work with the data, and you have the lawyers. I mean, the better systems you have, the more easy it is to comply.
So the problem potentially, and I want to know if you agree, is that with increased regulation and increased amount of work you have to do to conform with all the requirements you have to do, it will actually increase the divide between what a startup can do and what larger corporations can do. Do you think that's a problem? Would you agree with this?
I mean, personally, and the regulation that I come into contact with is with GDPR. I feel that it's only a blessing. It's so easy to have, whatever your intuition is about, is this a fresh thing to do with someone else's data? Now you're not allowed to do it. I really don't see any problems. And, I don't know what the use case would be for a startup to play around with my personal data in a Google spreadsheet or something.
But I think now this is very interesting, because I'm thinking you're proving the point on the AI divide in person. Because a person that is working on this in a mature way, in a mature company, and who has understood GDPR, has the training and has worked on this problem, and you have encountered this problem before and after, and you've been on your mind about it, it is a sigh of relief, because now I can understand these playing rules, and I can tackle that, no problem. If I go to a less mature person in this field, they get paralyzed. So I think we are now, you are actually in one way, you're not scared of it because you know and understands how it works and what it means. The scary point is for the people who are not deep understanding the data implications of it, and they get paralyzed. This is how I interpret when you say it's a relief.
I mean, this is absolutely my personal opinion, but maybe some things you maybe shouldn't be doing if you don't have perfect understanding of what you're doing, which is, for example, dealing with other people's personal data.
But just take a clickstream, for example. Yep. You have, where people are clicking on Aftonbladet and whatnot. You have that data, and that can be considered as personal information if you know who was doing what, etc. Right? And then a startup comes up, and they have an awesome idea of how we can use the clickstream to come up with a completely new way, innovative way to do churn prediction, for example. you could never in Schibsted publish a data set with that data that would enable people to innovate on it, right?
That would be very hard.
Yes. And perhaps rightly so. But you see the point here with it's hard to, if you take the problem with GDPR that you have to say in advance what you're going to use the data for and let the users give consent for that. If you want to be innovative and say, I have a completely new idea, I want to use the data for that, you're not allowed to do so, right? And that could potentially be a limiting factor for innovation.
Yeah, it could be. But me as a user, would I want someone to do something completely innovative that I did not give consent to?
Let's say it's a way to minimize ads then. Yeah. Okay, so I want to have more relevant ads, and I want to, by simply showing me fewer ads, but only ads I'm really interested in, that would be a super useful thing for a user, and everyone should want that to happen. So you have less irrelevant ads being shown to me. If someone comes up with an awesome algorithm for doing so, that would be a benefit for the user. But can we even provide data to allow that type of innovation to happen? See my point?
Yeah. I'm in my head thinking about how to move data into this startup, so that they can manage it. And it has to be
compared to banks, for example. Banks have this kind of regulation that they are required to provide APIs with certain data. That actually enables people to innovate quite a lot. So we have a lot of financial startups coming up now because of that, and I think that's a nice thing, right? But we don't have the same type of innovation, I think, happening for a lot of other types of data, and I would argue that's because of GDPR.
Interesting.
I'm not saying we should remove GDPR because the intention is, of course, awesome and we all should have it. It's just we need to do it in a way so it doesn't hamper innovation and startups. That's what I'm trying to say.
And why is that a problem? Well, I answer it because in other parts of the world they don't have those hampering handbrake sort of thing. Yeah, so this becomes a problem because on a global scale there's an uneven playing field. I would argue, because if GDPR was the policy everywhere and everybody was following it, it would be an even playing field again, and then we could figure it out. But isn't it that it's so local in some ways? So if I take, is that the problem?
I don't know. Because I think Facebook was threatening to remove all the services from Europe recently, actually.
But it's hampering innovation. Well, if it's in an even way hampering innovation, is that a problem? I think it's the uneven hampering of innovation that is the problem.
Yeah, well said. I think so too.
Difficult questions.
Yeah.
I mean, so a lot of the data that you're talking about is also of a different domain, like tabular data, clickstream data. That is something that hasn't been developing for what I think mainly is another reason. It's not an easy format of data to work with. Where we have seen development is, I think one strong reason is in image and text. It's a super simple format. It's portable, easy to work with. It's not easy to work with, but it's at least portable. A lot of unstructured and weird data that we have in companies. I mean, we're struggling sometimes to, organize it ourselves or, have a systematic format of it because there's so many different ways you can do it. So I would doubt that portability of this data and the legal constraints is the biggest problem. It feels like there's a lot of things we haven't solved yet for tabular data, which is the most common, probably.
That's interesting. So the tabular data, if you ask your database guys, they will think, this is the easy part and the unstructured data is the hard part. But you're arguing actually tabular data has other complications. Because they have different semantics, they mean different things, and
so if you have a database person, you probably have it already in simple tabular data, but I know a lot of companies, including us, we have rather went into very nested and advanced JSON structures, which is suddenly forces you to think of new ways to, you can't put it in a database. You have to either use maybe specific databases that can handle those data, like, what do you call it? Snowflake, or maybe you have to use Spark, and if you need Spark, you need a billion engineers to understand it.
Tough things. I mean, there are so many things we need to solve, I think, to make data available for everyone and AI available for everyone. And it's not the technical skills are a hard problem, but there are much more that you need to be able to cope with to properly do it in an ethical and legal way, so to speak. Awesome. Perhaps we should end in some more positive and fun topic than legal constraints.
It's a good topic, but let's do a fun topic if you have one you think about.
And there's so many here. But okay, if we take a general one, AI can be used and data can be used for so many different topics, and we have so many challenges in the world that we have today. We have climate change happening. We have poverty. We have problems with education. We have an energy problem. We have so many things happening. We have medical pandemics happening, and we need to find better ways to do that. But we also have abuses of data in so many ways, and deep fakes back and forth in different ways. But if we take all these into context and think, would you be more an optimist or a pessimist in what AI will do in coming 5 years? Will AI be more used for abuse or more used for positive consequences when it comes to society?
I feel like the time for abuse is sort of over. We've moved into what to do with AI, what it was intentionally defined for, in my definition. Statistics, like simple things. Statistics was used to make beer slightly cheaper to produce. A lot of statistics.
That's a good purpose. That's a very
beautiful purpose. Beautiful purpose.
Beer price is going to go up because of the lack of malt or something. It's a big problem with the Canadian harvest or something.
Maybe we can fix that. But yes. I mean, I really think that the big gains in AI machine learning is going to be incremental. That we can make big problems incrementally better. Yeah. I've sort of lost a lot of the hopes in these big leaps, at least for now.
You don't see. I mean, like I've shared this picture. I've used it in many speeches. That AI is not the flick of a switch, and then you're AI ready or you're AI. So this is a journey. And we will, for the foreseeable future, I'm quoting myself, drip feed more data, more algorithms, better algorithms into any process we use. So any business process, anything we do, will we drip feed more smarter ways to use data and AI. It's a journey.
Yeah.
And that's what you're saying. It's going to have a huge impact, but it's going to creep up on us because we're going to drip feed into better data and more algorithms.
It takes a long time.
And it's going to have huge impact, and it's going to be the impact everybody promised, but it's not going to be a flick of a switch.
I think it's going to have a marginal impact, but marginal impact is a good thing, but over a long period of time.
But if you go on that marginal impact, and you're thinking about compounding effects.
That's true.
So you have 5 different items in the process, and then are marginally improved with 1% in each one. The compounding impact is fantastic. And I think this is how you get to 10x with AI.
Yeah, and perhaps Ray Kurzweil is correct with his exponential increase in power in different ways. Who knows?
Mm-hmm. But that's really where I hope it's going to go. Also when a lot of people that maybe have been focusing a little bit too much on speech, text, and language are moving into this, boring fields of AI. Whatever it's going to be, that's where we get time series, we get healthcare stuff, we get boring tabular data that we can suddenly do things with.
But now we're connecting back all the way to who is Who is our guest today?
Yeah.
What did you start with? I love boring
fun solutions.
Boring problems. So it's a little bit back to, there are so much things we can do with more modern technology approaches and algorithms. Back to the basics, but with the not basics in terms of how we solve them, but the core problem, the core data.
That's another T-shirt. Boring problems, fun solutions. Egil Martinsson, right?
Yeah, that's a great one, Egil.
That's an awesome.
Really good, Egil.
Egil, what's next in your life? Privately, professionally, do you have anything happening?
I think hopefully we'll take a short trip to Palo Alto. I'm just going to be taking it easy and getting a sense for,
just for vacation?
Just for vacation.
Yeah.
Okay. So you're taking a vacation to a place that is sort of a ticking...
Yes, hopefully my girlfriend will visit a school there for a while to do some research. And so that's what's next in my life.
A little bit longer vacation, it sounds like.
No, it's just a little trip, actually.
Okay.
But
awesome.
In my life, I'm just trying to, right now, I've been focusing on, being a better engineer, learning the habits of what it takes to run a big systems.
Do you have any sightseeing plans for coming in Palo Alto and going to go to Hacker Way 1 streets? Or
that's what I hope. I hope that they've started up doing meetups there because I really want to check out what's going on in that scene. But maybe Silicon Valley is out. It's last.
I don't know. Corona-wise, I have no clue.
I don't know.
Maybe it's not cool anymore.
No.
It's still cool.
I think cool.
I think hopefully it's not accelerating at least anymore as it has in the past. And I think that's a good thing if it's not. And I think that's the case actually. But who knows? Awesome. Do you have anyone that you would recommend to this podcast? That's someone that you would like to listen to as well?
So I think you would have a very good discussion with Agnes Stenbom, which is she's a PhD candidate and thinking deep and a lot about ethical AI and how to do and also legal and political aspects of AI. She's interesting. She's at Schibsted as well.
Yes,
she's.
That's a topic we haven't really touched that much.
No,
yet,
because we've been talking about we are talking about ethics a little bit, but we have also to get to political or geopolitical dimensions of AI. We have said that would be super interesting. So that is a good idea.
She also has made this framework that we're trying to use now, which is called FAIR, which is a sort of a...
Did you have to call it FAIR as well?
Okay, yeah.
Do you know Facebook AI Research? That's the acronym for FAIR.
Maybe I'm citing it wrong. It could be it. But otherwise, which is, practical guide to how you can think when you're starting a machine learning project to not do anything foolish.
I remember actually we want to use the FAIR acronym as well at one point, but then when we saw it was Facebook AI Research, then we can't use that. But now the Meta AI, so perhaps it's okay to use FAIR again.
It's actually fast.
Oh,
it's fast.
Double
A.
But you were at PAL, right?
Yes, exactly. Ontario AI Research.
What Spotify was that? SAR? Well, how did you get to the F? SAR?
No, we should have that. That's a good question. Egil, it has been a true pleasure to have you here. And I think, I don't know how many topics we didn't have time to cover, but perhaps we can continue that discussion in the after work as we usually do. But thank you very much for coming here. It's been a true pleasure to have you here.
Awesome conversation today. Thank you very much.
Thank you for inviting me.